Brick has a natural beauty and comprises a living tradition. It is the best of the past, translated into current terms and needs. And the consumer's preference for this tradition of brick excellence remains as strong as and then packaged and stored until shipped. Let's see how they win the clay, the quarrying and mining to bring raw materials to the manufacturing plant ready for processing. We use three basic sources. They are the fire clays, shales, and surface clays. Fire clays are taken from deeper within the earth, sometimes being extracted from deep mines. Shales are also found near the surface, but in this case, they possess a much greater hardness than the surface clays. Surface clays are pliable and moldable, whereas shales have already gone to the rock stage, so they have to be blasted out and recrushed. Other than that, they are the same materials. Through most of the 20th century, steam shovels dug and extracted from the surface the clay destined to become brick. Today, equipment like front-end loading bulldozers are common, as is blasting. Quarries are typically close to the brick plant. Often getting the clay to storage and ready to process is merely a matter of trucking it across the road or across the pit. Most brick manufacturers do stockpile supplies of clay. But there's a definite strategy here, even before the brick plant is running. Locate the source of clay and build next to it. That's the principle. They conduct test borings, guided by big geological and topographic maps. The next step in making brick is crushing and grinding. If the basic raw material is shale, it must be crushed into small particles. Here the clay is going through the primary crusher, where steel teeth crush the clay into particles the size of golf balls. The result is transported to massive grinding wheels that grind the clay down to finer particles. In the grinding and crushing plant, the product is screened through a calibrated size of mesh. Chunks that are too big to pass are returned for further crushing. Sometimes we use the hammer mill, a device which hammers the particles into an extremely fine grind. If the clay at this stage has too high a water content, the screens will be heated. It's in the forming process that brick manufacturing methods differ the most. However, always up front is the pug mill. The pug mill was probably the invention that marked the beginning of the truly mechanized era. Forming is the real heart of this stage. Not only are you forming the brick into its size, but this is where most brick makers put on the texture and perhaps the color. Forming is the process of making the brick take on its final, acceptable, recognizable shape. Forming usually means an extrusion process, and this is the most common, where the clay contains about 12 to 20% moisture. If the moisture content were higher, denoting the soft extrusion process, more intricate shapes could be formed, and it's easier to make frequent changes in the batch configuration. A forming die is connected to the output of the pug mill and determines the external dimensions of the brick units. Clay is forced through the die onto a conveyor belt. The continuous mass, shaped in 2 of its final dimensions, travels 8 or 10 feet. It is at this stage that textures or coatings or both produce the color effect so prized in beautiful brickwork. Finally, the extruded clay passes by a set of rollers, whose effect is to shape the edges. The extrusion machinery can form brick whose core is not a solid continuous mass, but which has holes like these designed into it. Brick can be cored to save clay and fuel. But the primary reason is for stability and consistency of the drying and firing process, since heat will be allowed to get around the brick uniformly. It avoids a non-linear heat differential. Cracks won't be formed and the brick core and surface are thus optimized. The extruded clay is then cut by strong wires into individual green bricks. Green defines a brick before it's been fired into permanent ceramic hardness in the kiln. After applying the texture or coatings or both, the brick is cut in its short dimension by the wire cutters. Reel cutters hook onto the conveyor belt and produce cut green brick like a bread slicer. Or push-through cutters force an extruded column through the set of wires. As the conveyor line comes from forming, the brick must be removed and placed into something to hold it for drying. That process is known as hacking. Hacking may be done by hand or by machinery. When using machinery, like this push-through cutter, the brick are then immediately spread apart and mechanically placed onto the kill car by an automatic hacking machine. There are inflatable airbags which separate the cut green brick from each other. Brick are then loaded onto cars for a trip through the dryer. The hacking machine can set brick onto a car in different patterns and thus obtain the proper heat distribution through the brick during firing. Molding is a second means of forming brick. Again, we start at the output of the pug mill. Clay comes out as a slug, which is then forced into wooden or metal molding pans. Because this clay is wetter and is going into a mold, we need to coat the mold with light sand, usually, to allow the clay to release from the mold. Or there can be a water-struck process, which wets the mold heavily and allows a slug of clay to be formed and easily released from the mold. Again, sanding can be used to change the color of the brick. Racks are used in the molding process because the clay is too wet to stack on the kill car right away. Wet brick are set on the racks and put into a pre-dryer where the moisture is taken out until they can be picked up by hand. Bricks are stacked into the kill car and sent to the dryer. The hand molding process allows the creation of special shapes, sizes, and designs of brick. An extruded slug of clay is delivered to a custom molding table. A brickworker picks it up by hand, throws it into the mold, shapes it by hand, and empties it by hand. In this way, we can make truly unique and special shapes. Hand making still makes sense when the run is small and real craftsmanship is called for. A third means for forming brick is the dry press. Dry press forming creates brick of great dimensional precision and beauty. It's somewhat rare, although it may be returning to the scene. The clay comes out of the pug mill so dry it's granular, rather than as congealed thick clay. It's directed into a steel mold, and then a powerful piston rams it into the mold, much the way a concrete block is formed. The corners will be razor sharp, perfect every time. If there's a need for special textures, dry pressing is one of the best ways to do it. Now, the formed green brick is dried, using heated air, the waste heat given off by the high-temperature kilns. Drying is not the high-temperature firing we'll see in a few moments. Drying removes all but a small percent of the water from the green brick. Typically, there's a tunnel dryer, similar to a tunnel kill, where the cars move over a period of hours, usually about 24 hours. The dryer is taking the moisture down to about 1% before firing in the kiln itself. After drying, the brick undergo firing in the kiln, an enclosed, very hot environment. The tunnel kiln is the most widely encountered, although its size and appetite require a truly large-scale operation to justify its use. The still green brick are pushed on specially insulated rail cars through the tunnel and its various zones of heat and cooling. Firing starts with low heat and continues up to a point around 2,000 degrees Fahrenheit in the firing zone. The brick pass into the cooling zone. The process of maturing the brick depends on both time and temperature. The length of time that a brick is held in the high temperature zone is critical. It allows thermal and chemical reactions to actually turn the clay into a ceramic entity. The entire firing process takes approximately 48 hours, depending on factors like the appearance of brick desired. This refers to flashing or adjusting the oxygen content in the firing zone, causing a deposit to form on the brick surface. Fuel and heat can be supplied to a tunnel kill in a variety of ways, sometimes from the side and sometimes on the top. The decision on where to situate the burners depends on how the clay will respond. It's an intentional design factor. Even after years of work, the brickmaker can adjust the process by adding a burner here or there, or changing the heating pattern. The kill car itself is interesting. It's like a railroad car underneath with a high-temperature ceramic bed which protects the car from extreme temperatures in the firing zone. The bed is of insulating fire brick. Periodic kills generally don't require the continuous heavy volume of input because they don't operate constantly. These operations are set up to fire the brick in batches. We start with an empty kill, like this one, and fill it with green brick, usually employing a forklift truck to stack them. Then close it up. In the case of a beehive kill, it's actually like building a brick wall, which becomes the sealed door. The shuttle kill is more modern and is rectangular in shape. Its doors are moved rectangularly, whereas the beehive door was built up by hand each time. Natural gas is the most popular fuel for the extreme heat of firing. It accounts for 75% of the installations in this country. Other fuels include 5 to 10% oil, 5 to 10% coal, and yes, wood in the form of sawdust. The choice of fuel is based on the local economy and supply. For example, the modern coal-fired kiln uses coal ground to an extremely fine powder, which is mixed with air and blown into the kiln. It has the same heating effect as gas. Now, when wood is used, and wood is the fuel, it's actually waste sawdust, dried and ground to a very fine powder. Brickmakers are concerned about the impact of their operations on the environment. For example, stormwater runoff. It could carry away pollutants, so the operator designs or modifies the plant to prevent clay from running off into streams. Air pollution is a concern. Because of the amount of fuel burned, strict regulations are applied to stack emissions, varying from slight to complete bagging systems, which trap every particle. Brick companies observe the same reclamation and environmental standards on mining or winning that apply to all mines. When the quarry or pit or mine is exhausted, it must be restored to ecological standards set by the government. These sites are often sought as landfills. Today's brick-making plants store and package their product for ultimate safe delivery to the building site. As brick emerge from firing, some brickmakers carefully select and sort by hand for color and other characteristics. For example, the selection criteria might be 50% dark, 20% light, the rest medium. Packages of brick are put together with a steel band, usually in batches of 100 to the pack, with voids, holes at intervals to accommodate the points of a forklift. The 100 packs are usually bound together into a larger 500 brick unit. That unit may be shrink-wrapped with plastic to protect it from the elements and the climate. Getting an order of brick to the customer usually means shipping by highway truck. These are the methods by which today's technologically advanced plants, along with scores of more traditional brick-making operations, produce beautiful and varied brick, a building material once limited to kings and noblemen, which now enhance our environment almost everywhere we go.